So far, we've seen the analytical method and the graphical method to solve nonlinear circuits. Next, I'd like to very briefly introduce the piecewise linear method. And I just want to caution you that we won't be spending a whole lot of time on this method in this course, but I just want to give you a feel for the method. And if you want to know more the details about it, I recommend that you look up section 4.4 of the textbook. And there are lots of detail, lots of examples that you can read about this method. So in the piecewise method, here is the key piece of insight. And here's where the method is useful. Supposing I have a device, some hypothetical, or some real or hypothetical device. Let's say it's a nonlinear device. Let's say it has this curve. The ID versus VD relation is some nonlinear curve. Now, the piecewise linear method says the following. It says, take your nonlinear curve and try to approximate that using linear segments. And then once you approximate that using linear segments, then if you know that your operating point is in one of those segments, you can apply linear techniques. So in this particular situation, let's say for the hypothetical export dweeb device that I had, this is the curve, this is the VI relationship for it. So I'm going to make a gross approximation. Okay, I'm going to say, so let's say I use 0 for the value of the current when the voltage is negative, and then let me go ahead and approximate the current for positive values of V using that part of the curve. So let me call the left-hand side a linear region A, and let me call the right-hand region linear region B. So what have I done here? So simply put, I have taken my nonlinear curve and approximated it with a pair of straight lines. So what I'm saying is that for the purposes of solving my equations, I'll use a simple engineering trick, which is use approximations, and I'm going to use this pair of straight line approximations to represent the function, the curve for this device. Once I do that, then the solution techniques will be the following. If I build a circuit containing the device, then what I'll do is I'll first try to figure out which linear region applies for that circuit. Okay, and given the known parameters, I should be able to figure out which region applies. Okay, so let's say, for example, linear region B applies. If linear region B applies, then I can solve the circuit using the linear relation from B. So in this case, if the linear relation from B applies, let me pause for a few seconds and see if you can figure out what would you replace the device in the circuit with if the linear region B applies. Okay, what would be the linear element you would use to replace the device in the circuit if linear region B applies?